Greetings, I'm Bill Endres. I teach at the University of Oklahoma and research early medieval manuscripts. Part of my research is advanced digital imaging and recovery techniques. Today I'm going to demonstrate how to apply methods of statistical analysis to multispectral images and recover damaged medieval text. Today's example is a special case. Because of success raising cattle in the British Isles, early palimpsests are rare. In this video, I provide a look at one of these rare manuscripts, the Hereford Gospels. For multispectral images, you take a series of photographs using a variety of light frequencies, from ultraviolet to infrared. Each image is grayscale. While multispectral images provide glimpses of visual information normally not seen by the human eye, rarely does a single image reveal enough information to make damaged text legible. Therefore, recovery methods are necessary. The most successful methods are statistical analysis, specifically principal component analysis, PCA, minimum noise fraction, MNF, and independent component analysis, ICA. These methods analyze the value of pixels across the whole set of multispectral images. They identify pixels with similar characteristics and create a whole new set of images, with each image containing pixels with statistically similar information. For example, PCA begins by calculating the variance for each pixel across an entire set. It separates these pixels into a collection of percentiles. It renders a new image for each percentile. The goal is to have a few images that the visual information for the damaged text dominates. To apply these statistical methods, I've written a set of Python scripts. They make it quite easy. First, let's look at a set of multispectral images. This folder has 4 multispectral images. I'm using just 4 for 2 reasons. First, these 4 contain most of the visual information for the palimpsest text. Second, using 4 rather than 20 multispectral images speeds up the process. Andy Beebe and Richard Gameson captured these images. The Python scripts for the methods of analysis are in this folder. Here is my ICA script. All I need is to double-click it, and then it opens the IDLE shell, which runs the Python script, and here's my code. Next, I click Run Module, and the script begins. It asks me for the folder where my images reside. Then the script asks me to select a region of interest. In the lower margin, you can see where some palimpsest text, while not legible, is visible. Let me select a large portion of it. The script is now analyzing each pixel across the set of images and determining which pixels have similar characteristics and belong together. It's finished. Now I can run my PCA script, which also asks me for the folder with the images. You can see that in the folder, there now exists a new folder with my ICA results. Again, the script asks me to select a region of interest. Using the region of interest, the script calculates its percentiles and applies those percentiles to the set of images for the whole page. Okay, the process is complete. Let me move this out of the way. Let's look in our folder and see the results. Let's start with the ICA folder. The first image doesn't include much visual information for the palimpsest text. Not much in the second either. The third one is pretty good. The palimpsest text is much more visible. The fourth is also rich with data, but the image shows the palimpsest text as whitish rather than dark. We can invert this image easily enough with graphic editing software. Let's go back and look at the PCA and the NNF. For these, I just wrote one script to apply both methods. Not much. Not much. Okay, we have one that shows the palimpsest text is lighter. We have some darker palimpsest text here. This one's pretty good, and this one's pretty good. To make a pseudo-color image and increase contrast, we can select 3 of these images generated by the scripts and combine them into a color image. To do this, I normally use ImageJ. ImageJ is graphical analysis software developed by the U.S. National Institute of Health. It is free to download and use. Let me load a couple of images into ImageJ by dragging and dropping them. Let's use the 3 images with the darkest palimpsest text. Reduce this. I think 3 looks to be my strongest. The text in the M and F appears lightest. The other PCA is in between. Let's combine these images and see the results. Now, I could use an image from my ICA analysis, but for speed, let's not, and see how we do with these 3. Let's start with PCA 3, place it in the red channel, then PCA 4 in the green channel, finally NMF 4 in the blue channel. Because these images do not represent data for red, green, and blue light, the merged image will be a pseudo or false color image. And here's what we get. We have fairly readable text. Notice we can easily read a B, an O, an N, a C, and another O. We likely have an R here, and a D, and an E. We have some good legible letters and even a word. So let me save this image. In naming an image, I include information about the images used and their order. This way I know which images produced this result. Rarely does one pseudo-color image provide the best visual information for every letter, every word, every line. Normally you need to generate multiple pseudo-color images using different combinations of results to recover as much of the palimpsest text as possible. Normally I would go back and merge the best ICA image with different combinations of the PCA and NMF images. I would pay particular attention to where I might be gaining better visual information for different areas of the page. There's one additional digital method I use once I have a pseudo-color image. Let me load my saved pseudo-color image into ImageJ. ImageJ has a plugin called dstretch. It was developed by mathematician John Harmon. dstretch provides a way to easily perform a range of decorrelation stretches to increase contrast and sharpen the view of the recovered text. Normally when color is adjusted, such as for hue, all colors are adjusted linearly. A decorrelation removes the linear relationship between colors, allowing them to be adjusted individually. For example, you can stretch a color like blue across its whole numerical range without affecting other colors. The dstretch plugin for ImageJ makes it very simple to do this. It has over 40 presets to decorrelate and stretch various colors. To provide so many options, dstretch takes advantage of alternative color spaces. All that is needed is to click on dstretch buttons and it will show the results. Here, blue is enhanced and the palimpsest text sharpens. When I have a good result, I save it. I test a number of different possibilities. You can see that some of them make the palimpsest text less visible. Others produce good results. Now, YKB produced a strong result. If I compare to our first result, I'd say the first is still a little better. If an image has a lot of darkness, sometimes the stretch lightens areas and makes the text stand out more clearly. Again, dstretch provides over 40 preset options for generating better contrast to sort a text. I don't have time in this video, but if 40 plus aren't enough, Destretch allows you to customize and make adjustments to stretches. This one is fairly strong. So again, I'll save it. Because different letters, words, and lines are enhanced differently, recovery is a slow process. I work through images multiple times, using different regions of interest, trying to generate enough contrast for each line and word to stand out, regularly making the text legible, letter by letter. While time-consuming, digital recovery is magic. It generates more information for scholarship, and it brings the medieval world more clearly into focus. Thanks for watching.